Hello all, welcome to the SPAG video series. In this video, we're going to see how to create a EPL or an ELINE based service between two customer sites which are located remotely. The two customer sites are CE1 and CE3. The service provider network will create a virtual connection between CE1 and CE3 so that the two sites can communicate with each other. The service provider network is comprised of two access nodes, R1 and R3, and two more nodes, ASR 9031 and ASR 9001. The ASR 9031 and 9001 are the edge nodes of an MPLS IP-based service provider core network. There are two different configurations, or there are two main configurations that needs to be done in order to enable or in order to form a EPL-based service. On the access nodes R1 and R3, layer 2 configurations, EVC configurations have to be done. On ASR 903 and 9001, we need to create a pseudo wire to carry the layer 2 traffic across. So let's look at the R1 configuration first. Getting into the interface which connects CE1, you could see that we've created a service instance 1, and it encapsulates the traffic .1Q100. The customer is sending with a VLAN tag of 100, and the service provider is pushing a VLAN tag of 200 on top of it to distinguish the customer traffic. So the customer traffic going into the service provider network will have two VLAN tags, 100 and 200. It's switched with a bridge domain ID of 100. Do keep in mind the box here, the access node here, or the R1 is a Cisco ME3600 box. So the switch port trunk allowed VLAN none, and the switch port mode trunk, these are the two mandatory configuration in order to enable the service instances configuration on the interfaces. Now the traffic is switched to the core or to the core network using the interface show interface gig it's show run interface gig 0/2. So here we are using the same configuration CLI, so service instance 1 Ethernet, and I am matching based on two VLAN tags because we pushed another VLAN tag of 200 on the interface which was connected to the C, and we are going to switch the traffic through the same bridge domain 100. So once the traffic is switched from R1 to ASR 903, now we're going to look at the R3 config as well, just to see if it differs or if it's the same config as the access node 1. It pretty much is the same config as the R1. So if you look at it, I'm matching the customer traffic with .1Q VLAN 100, and I'm pushing a tag of 200. So on the interface which connects to the core gig 0/2, I am matching the traffic with a VLAN tag of 200 and 100, and I'm switching through the same bridge domain ID 100. So we looked at the access node config. Let's look at the core edge nodes, right? ASR 903.1 and ASR 9K1. So ASR 903.1, the interface which connects to CE1 is show run interface gig 031. Here again, I'm creating a service instance to match the traffic which is coming from to match the customer traffic. And again, do keep in mind it's two VLAN tags, 200 and 100, and I'm popping both the VLAN tag before it's sent across the pseudo wire to ASR 9000 on the other side. The XConnect config is the one which helps me form the pseudo wire to the remote edge node, which is ASR 9001. This is the IP address of the ASR 9001, and I need to define a unique VC ID for the pseudo wire, which is 100, and the encapsulation used here is MPLS. Going on to the ASR 9K, the ASR 9K runs a different operating system, which is an iOS XR. So first we will define the EFP, and the EFP is defined using the following commands. 0009.100 is the EFP that I've used here. Again, the CLI is a little different from iOS XE. In iOS XE, you use a service instance, whereas here we define the service instance as something like a layer 2 sub interface. And again, the encapsulation is the same. I'm matching based on two VLAN tags, 200 outer, and then the second VLAN tag of 100. I'm popping the two VLAN tags before I send across to the pseudo wire. Do keep in mind, in iOS, we define the configuration of creating a pseudo wire under the service instance itself. Here, we have to actually get onto another CLI called, or a major CLI called L2VPN. So I define L2VPN, I define Xconnect group. This is more for easier configuration management. And then I define the point-to-point service, just give a name for the point-to-point service. Once that is done, I define the interface from where I'm going to send the traffic or receive the traffic from the customer, and I define the pseudo wire as well. So I define the neighbor, the loopback address of ASR 9031, which is 1.1.11, and then the pseudo wire ID 100. This should match with the pseudo wire ID that I had on the other side on the ASR 903. Once that is done, your configurations are complete. First, let's check whether the pseudo wire has been established. So in order to do that, I do a show L2 VPN Xconnect detail. Here I see that the attachment circuit, which is the EFP, is up, and I look at the pseudo wire. The pseudo wire status is, of course, it says up and established. That means the pseudo wire has formed. You can look at the additional parameters of the pseudo wire, the labels that are exchanged for the pseudo wire establishment, the MTU, and the control word. It's disabled on both the sides. The pseudo wire type is Ethernet. You could also look at that. Let's actually verify the pseudo wire on 903. Let's find out what the configuration is on 903 in order to verify the pseudo wire operation, whether it's up or down. So show MPLS L2 transport, and then I say VC. What is the VC ID that we use? That is 100, and I say detail. So once I do that, you see that the pseudo wire is up. You see that the VC status is up. That means that the pseudo wire has been properly established. Now we have a ELINE formed between CE1 and CE3. ELINE service formed between CE1 and CE3. So the CE1 will literally see the connection to the CE3 as a layer 2, a virtual layer 2 connection. So it will literally see the connection going to CE3 as a layer 2 wire. Now what I've done is on CE1, I'm going to just quickly verify whether my service is working. So I'm going to get on to CE1 and CE3. On CE1, R1 and R3 are configured to receive traffic with a VLAN ID of 100. So I'm going to send the traffic with a VLAN tag of 100. So the interface, the CE3 and CE1 interface connecting to R1 and R3 are configured as trunk, and I've configured an SVI with VLAN ID with interface VLAN 100. So if I look at it, there is an SVA configured with a VLAN ID of 100, and it has an IP address of 1.1.1. I've done the same thing here, but of course with a different IP address, VLAN ID of 100 with an IP address 1.1.2. Now, since the ELINE service that you created between CE1 and CE3, you should be able to ping from CE1 to CE3. This should appear as a wire, right, layer 2 wire. So what I'm going to do is from CE1, I'm going to ping the IP address of CE3, which is 1.1.2, right? So I do a ping 1.1.2. Let me do an extended ping with, when I say extended ping, let me do ping with more packets. So let's say 1000. And for me to make sure that the packets are switched properly, it's going through the ELINE service that I created. I'm going to just quickly look at the statistics of the layer 2 VPN that I created. You see here that the packet switch are more than 1000. I did some pings before, so it's showing more than 1000. But you can clearly see I do another 1000 ping, and I refresh the command again. It takes a bit of time, so if you do, you see that the packets have increased to 2000. That means that the packets that you're pinging is taking the ELINE service that you created, or the pseudo wire that you created. So this marks the end of the video for the ELINE service creation, or EPL service creation. I hope it was knowledgeable, and I hope you have a fun time configuring ELINE services in the lab. Thank you.